Let's look at this. We need to find the partial fractions of this. How? As you can see, this denominator, they are not all linear. Look at this guy. But we need to first of all make it linear. How do you make this linear? That is, when you have anything like this, remember, it's something like this, a squared minus b squared, which is equals to a minus b, a plus b, or you rewrite it as a plus b, a minus b. Okay, so therefore, we are coming here now. This equals to 2x raised to the power 2 minus 3x minus 10 over. This is s plus 2. No issue here now. Is like you are writing s squared minus 3 squared. This will give us s minus 3s plus 3. Okay? To replace this. These two, we replace them. With this now, we are good to go. Okay? Now, all we need to do, this is equal to a over this plus b over this plus c over this. Okay? Once we are here now, we use the cover-up method. To get a, we cover this guy here. That is s plus 2. We cover it. What is remaining is this. That is 2x squared minus 3x minus 10 over this. That is s minus 3s plus 3. After covering this, this is what is remaining. Okay? Now, how do we get a? To get a, we go back to what we covered. It's s plus 2. We equate it to 0 to have s equals to minus 2. So we say let s be equals to minus 2. Just a process. It's a process. Then we substitute minus 2 raised to the power 2 plus 3 minus 2, 10 over minus 2 minus 2. Okay? Then we square. If you square this, you have 2, 4. This and this will produce 6. Over this will produce minus 5. This will produce 1. Okay? That is 8 plus 6 minus 10 over this will produce minus 5. Which is 14 minus 10, which is 4. 4 over minus 5. So a therefore is minus 4 over 5. Once we get a, we can go for b now. Let's go for b. b, we are going to cover this here. That is s minus 3. We cover it. What is remaining is for b. That is 2x raised to the power 2 minus 3x 10 all over s plus 2 s plus 3. Okay? Now, how do we get b? You come back here. I equate this to 0. S minus 3 equals to 0, which is s equals to 3. So we say let s be equal to 3. Then we substitute. That is, b therefore is equals to 2. We put 3 here, we put square. We put 3, put minus 10. We put 3 plus 2, 3 plus 3. Okay? Now, we solve. This will give us 2, 9, minus 9, minus 10. All over. This is 5. This is 6. This is 18, minus 19. All over. This will give us what? 30. Which is equals to minus 1 over 30. You agree with me? Therefore, b is equals to minus 1 over 30. That is our final answer for b. Now, let's go for c. For c, we are going to cover this. Whatever that is remaining is for c. So we say c now is equals to 2s squared minus 3s minus 10 all over s plus 2 s minus 3. Okay? Then this is what we covered. Equate it to 0. If you equate it to 0, what are you going to get? You get s now equals to minus 3. So we come here to say let s be equals to minus 3. We substitute. Okay? Now, we continue. That is 2, 9, 9, 10, minus 1, minus 6. Okay? You agree with me? This is 18 plus 9 minus 10 over 6, which is equals to this, and this will produce minus 1. You apply it here, you have 70 over 6. It means C therefore is equal to 70 over 6. Let's pick each of these as substitute. The first one is A equals to minus 4 over 5. So we come here to say this is actually 2s squared 3s10 over s plus 2 s minus 3 s plus 3 as equal to the first one again, minus 4 over 5 all over this s plus 2 plus the second one is b, minus 1 over 30 all over s minus 3 plus the last one c is what? 17 over 6. 17 over 6. 17 over 6 all over s plus 3. Okay? Now, we write this as minus 4 all over. We bring that 5 s plus 2. Then what are going to have minus 1 over s minus 3. This is 17 over 6 s plus 3. So this is the partial fraction of this question.